promised in today's lecture that I was going to make a video to actually simplify some problem that we actually went through in class today. But you know what? I first want to tell you this. You need to first, since this course, particularly this particular topic that we start require the knowledge of calculus and algebra. So I'm actually going to advise you to, um, you know, uh, reverse. Uh, you need to have a recap, okay, on what you've done before in both calculus and algebra, because that knowledge is very, very essential. You remember today I started my class from conditional distribution, okay, and of course, when you have S and Y that follow, where S is continuous, Y is continuous, and of course, you basically want to get f of Y given S, okay, which is the conditional function of Y given S. Of course, that is basically going to be the ratio of the joint of the function divided by the function of the marginal. And the marginal here is basically going to be the marginal function of X, okay, because we already given X. And of course, you can also extend that. What if in a situation where what you're looking for is f of x given y? So the f of x given y, you're still going to have that same function, but except that that will be divided by f of y. So which means if you want to get a conditional function, then you're basically going to need the joints and the margin. So which means you need to figure out how what the marginal is. So if your marginal is wrong, then the whole thing is basically going wrong. Okay, so the same thing also applicable to when the variables are discrete. You're actually going to see the difference between the two. It's more or less like I'm using A for continuous and I'm using P for discrete. Okay. Now, if you take a look at this example on X and Y, the range of X is from 0 to 2. Okay, the range of Y is also from 0 to 2, which means we got 3 by 3, right? So which is basically going to be 9, and that is why you have the numbers of probability that you have in that cell should be 9. Okay, because you actually cross tabulate 3 levels of X against 3 levels of Y. Now, what you're seeing now actually, represents the joint probability, between X and Y. Now, so many questions can be asked from this given table, right? If you take a look at question A, they said given X equal to 1, okay? Determine the conditional PMF. The PMF that you see here actually means probability mass function. Of course, anytime you hear probability mass function, we basically focusing on, probability of a discrete random variable. Okay. Now, if they wanted to find the PMF of Y, okay, how do I know? Oh, this is what they are talking about. I know that is what they are talking about because here the Y is a random variable. The levels of Y, according to the table I showed you the other time, it's actually 0, 1, 2. And of course, we've already decided here, according to this question, about what else it's going to be. Even though in the table, we also have 0, 1, 2. But here, we actually condition that not on the entire state space of S. Okay, we are only focusing on S equal to 1. So focusing on S equal to 1. So, if you take a look at this statement, I can possibly derive that is what they are asking me. Okay, now you're actually going to see 1 here, 1 here, 1 here. Okay, that is the value of X, which is 1. Okay, irrespective of the values of Y, that of X is already decided and it's basically going to be 1. Only that what you actually going to see changing is the values of Y. Okay, 0, 1, 2. Since we are actually interested in that of the PMF of Y. Now, you need to remember the formula because, the P of Y given S is actually P of Y comma S, okay, divided by P of X. Okay, don't forget, P of Y comma S is the same thing as P of S comma Y. Okay, I wanted to take note. So if you take a look at this guy now, okay, because they say the conditional PMF of Y given S, so it means what you basically have here is Y, okay, X, Y, X, Y, X. Okay, so if I want to figure out the first one now, I'm basically want to find, okay, which means it's more or less like Y equal to 0 given X equal to 1. Okay, the second one now is like, oh, Y equal to 1 given X equal to 1. And the last one, Y equal to 2 given X equal to 1. Okay, so that is the way I wanted to interpret P of 0 given 1, okay, P of 1 given 1, okay, and P of 2 given 1. So that is the way you're going to interpret that. So I'm now going to be making use of the formula here now. Okay, so if I want to figure out this guy now, okay, so I need P of 0 comma 1. Okay, don't forget the joint. I'm using this guy now, divided by P of X equal to 2. You see that? Here, I'm actually need P of 1 comma 1 divided by P of X equal to 2. And finally here, I actually mean P of 2 comma 1, then P of X equal to 2. So you're basically going to see that each of that, we're going to have the same denominator. You get what I mean? Okay, so all what you just need to do now is just for you to go to the table. Okay, what is P of S equal to 2? Okay, now P of S equal to 2, that's a marginal, right? It means you're basically going to sum across the range of Y. So let's say P of X equal to 2. Okay, when you take a look at this guy now, this is S equal to 2. I'm actually going to sum this guy. So 0 0.06 is 0 0.14 is 0 0.30. That would be 0 0.5. So which means my denominator is basically going to be 0 0.05. But I need to get the numerator now. Okay, now for the numerator, okay, when Y equal to 0, X equal to 1, Y equal to 0, X equal to 1, that would be 0 0.08. So it means the first one is going to be 0 0.08 divided by 0 0.05, which is exactly, let me see, 0 0.08. You see that? Let's add up when S equal to 2. Oh, so, well, like I said the other time, you're adding up this guy, right? Let me see what that guy is basically going to do. So if I want to find, am I working on S equal to 1 or sorry, S equal to 1, not S equal to 2. So I'm going to go back. Okay, this is it. You see that? S equal to 1, right? I'm working with S equal to 1, right? So S equal to 1 actually means I'm going to add 0 0.08 plus 0 0.20 plus 0 0.06. Okay, and when I had that guy up, so what do I have? I think that should be 0 0.34. Okay, so which means the denominator is basically going to be 0 0.34. So that's why I told you the other time the denominator of H is going to be 0 0.34, which is more or less the probability of S equal to 1. Okay, let me walk you through that again. S equal to 1, you're focusing on this area. Okay, Sx equal to 1, you sum that over the range of Y. So when you had that hub, that will give you 0 0.34. Now, when you have a 0 0.34, how do I get the numerator? So you're going to look at where Y equal to 0, S equal to 1. So where Y equal to 0, S equal to 1, that would be 0 0.08. So which means is 0 0.08 divided by the totality. Okay, it's 0 0.08 divided by the totality. That's what you have here, right? Now, if you want to do this, if you want to do for the one-on-one, okay, so 1-on-1, so 0 0.20 divided by the totality is 0 0.06 divided by the totality. That is exactly what you have here. So that is how to get the PMO for that. But here, if you take a look at the second question, right? The second question this time around is talking about y given x, except that x is, your x equal to 2, okay? We're still focusing on the range of y 0 to 2, but this time around, x equal to 2. We're going to follow the same thing here that we do. The only difference is just going to be, it's just going to be like 0 given 2, 1 given 2, and 2 given 2. Okay, so if you basically want to find, the probability of x equal to 2, because you need s equal to 2, right? Because they've um, already, given you here. It said to obtain the probability of y given 2, don't forget it's y given s. Okay, so what I'm going to do, let me first look at s equal to 2. Okay, looking like x equal to 2 is basically this guy. So I'm going to add 0.3 to 0.14 to 0.06. I think that should be 0.5. Okay, so the probability of s equal to 2 is 0.5. Okay, now if I want to, how do you think they got that guy? Okay, so that guy is basically going to be probability of 0, okay, given 2. That is the probability that y, it means y equal to 0 given x equal to 2. And don't forget, it's basically going to be the probability of y equal to 0, comma x equal to 2 divided by probability of x equal to 2. Don't forget, the probability of x equal to 2 has been decided to be 0.5. Don't forget. Now, I'm only going to go back to the table now, okay, where y equal to 0, s equal to 2. So I'm going there now. Okay, where y equal to 0, s equal to 2, that would be 0.06. So what I'm going to do here now, so I'm going to do 0.06 divided by 0.5. Okay, when you use that to divide that, you're basically going to have 0.12. That was what actually lead to this guy here. Okay, now if I want to figure that out, okay, the probability of y equal to 1 given x equal to 2, that is going to be the second one, which is going to be p of p of y, right? So which is like p of y given x. Don't forget our y is 1 now. I want to consider 1 now, so that's why you see here. So I'm actually going to have p of y equal to 1, x equal to 2, okay, s equal to 2 divided by the probability of s equal to 2. Okay, now the probability of s equal to 2, I've already obtained that to be 0.5, right? So, and what is, when y equal to 1, s equal to 2, where is that? Okay, y equal to 1, s equal to 2, that would be 0.14. So, which means I'm basically going to do, I'm actually going to do 0.14 divided by 0.5. So 0.14 divided by 0.5 will give you 0.28. Now, lastly, okay, how do I get this guy here? Okay, so getting that guy here, you want to do the probability of y equal to 2 given that x equal to 2. Okay, so the probability, so the join, don't forget, so that's going to be y equal to 2, comma, x equal to 2 divided by probability of s equal to 2. And don't forget, the probability of s equal to 2 is marginal, which has already figured out, okay, which is s equal to 2, adding up that guy, so which is 0.5, right? Okay, so you know the denominator, we already got in that 0.5. Now what is when y equal to 2, s equal to 2? Let's look at that. Y equal to 2, s equal, that would be 0.3. So 0.3. Okay, so 0.3 divided by 0.5, I think that should be 0.6. Okay, that was how we got this guy here. Okay, I believe you really understand that. So that is how we get the conditional. And of course, when you take a look at this guy, you want to figure out the probability of y less or equal to 1 given x equal to 2. Now, if you want to do that, For of us, look, consider a random variable, the probability of y less or equal to 1. So, which means you basically want to consider y equal to 0, okay? And y, y less or equal to 1 actually means you only want to consider 0, 1. Don't forget the range of y is from the state space of y 0, 1, 2. But y less or equal to 1 means I'm only going to focus on 0 and 1. So, and don't forget, you've been given that s equal to 2. So which means, okay, this guy here now will be 0 given s equal to 2, 1 given s equal to 2. That's what I'm going to consider. Now, which means if I want to get this guy now, I'm only going to focus on these two. And don't forget each of that is conditional probability. So we're basically going to use the idea of what we did before. Now, if you want to solve the problem of with this guy now, okay, so P of 0 given 2, don't forget, y given x, it means y equal to 0 and x equal to 2. So which means the probability of y equal to 0, x equal to 2 divided by the probability of x equal to 2. Okay, now what is the join? You're going to go back to the table. When y equal to 0, x equal to 2. Okay, when y equal to 0, x equal to, that would be 0.06, right? Then divided by the probability of x equal to 2. Of course, s equal to 2 is 0.5. Okay, so of course, when you do that, it's 0.06 divided by 0.5. That will give you 0.12. Okay, you're going to do the same to this guy here. Okay, you want to find that guy now. So don't forget, you're going to use the join again. Don't forget the P of y given s. Or it means you basically want to focus on, the joint is basically going to be the probability of 1 comma x equal to 2 divided by the probability of s equal to 2. Don't forget s equal to 2. That would be 0.5. We've already gotten that guy out. Now we need to go back to the table now. Okay, anytime you want to figure out the probability of the joint, that is the essence of that multiplication table. So I'm actually going to go back right now. Okay, so when y equal to 1, s equal to 2. So take a look at that. When y equal to 1, x equal to 2, that would be 0.14. So I'm actually going to write 0.14. So it's 0.14 divided by 0.5. Oh my God, that should give you 0.28. Then I'm going to add them up. And finally, this guy is basically going to give me 0.40. Okay. So that's how to go about that. Now, this very D here is the same thing as the way you do, this is like, what is the probability of S given, here is we're focusing on S given Y. The one we've been doing, we'll be focusing on Y given S. Okay, so here, of course, the rest S is going to be a random variable where Y is already decided, Y equal to 2. So if you want to rewrite, don't forget, if I have the probability of S given Y, okay, where I'm, S given Y, don't forget, I'm actually going to have the joints, okay, divided by the P of Y. Take a look at that. I'm actually going to have the probability of Y. Okay, and don't forget, now you've been given so because the nature of the x is a random variable, and the s is going to go from 0, 1 to 2. Okay, just like the way it is being displayed in the table. Okay, so what I'm just going to do now, okay, it means the very first one I'm going to consider is what can I figure out the probability of 0 given 2. Okay, I also need the probability of 1 given 2, and I also need the probability of 2 given 2. Okay, don't forget, I'm actually considering s given y in this case. Okay, so s given y in this case is more or less, if you look at the first one here, it's just like when s equal to 0, okay, when s equal to 0, given that y is already decided, y equal to 2, the next one, when s equal to 1, given that y equal to 2, when s equal to 2, given that y equal to 2, that is exactly what I'm going to do. So now, making use of this formula now, if I want to figure out or this guy now 0 given 2. Now it's more or less that I want to figure out why, the probability of, y is already 2 and x is now 0. Don't forget, divided by the p of y. Now, of course, the other time, the p of y, if I want to get p of y, I'm actually going to sum over the range of x, right? And this time around, been given that y equal to 2, p of y equal to 2. Give me 1 second. Let me write that. Okay. Now, y equal to p of y equal to 2. Okay. So if I go back to the table, okay, so if you want to do, if you want to find y equal to 2, you're actually going to sum column wise. Take a look at that. So it's going to be 0.3 plus 0.06 plus 0.02. I think this is more or less looking like 0.38. Okay, that's looking like 0.38. Okay, so that is what you have here. You see that 0.38, that is the marginal probability of y equal to 2. Okay, so 0.38 is what I'm actually going to be using as a denominator. So right now, so I'm actually going to put 0.38 right here. Now, the next thing is just to go back to the multiplication table when y equal to 2, s equal to 0. Okay, so when y equal to 2, okay, s equal to 0 will be going to be 0.02. Okay, so it's going to be 0.02. So when you do 0.02 divided by 0.38, that will automatically give you what you have here. Okay, now if you follow the same way, okay, you just need to come to this column, 0.06, 0.3 also. That is basically what your focus is basically going to be, for you to be able to figure out, or don't forget, in each occasion you are dividing by 0.38. So that is how to handle that. Okay, the one we actually want to, the next question now is basically going to be on a joint probability density, because the x and y are continuous in nature. And of course, here I told you, you need the knowledge of calculus, you need the knowledge of algebra. We need the knowledge of calculus because we basically going to perform antiderivative, okay? And we're also going to simplify. Okay, now take a look at this. Let x and y, play off for right and left tires, have density. Okay, s is 20 less or equal to s, y less or equal to 30. Now, if you take a look at this, it's basically telling you x lies between 20 and 30. Y also lies between the same, because we're talking the prayer. We expect that to have the same range, both the left tire and the right tire. You get what I mean? Okay, so having decided that, take a look at the joint. The joint, the probability now, a constant is k is there, need to be decided. Now, if you want to go by a way of solving this problem now, okay, you can first start, by first figuring out what is your k. Okay, now, well, so when you decide on your K, of course, you can answer any other questions here, even though I can do it without deciding on K. But I think if you want to follow what I've done in class, I will advise that you actually, first decide on your K before moving forward. When you take a look at question A now, say determine the conditional PDF of y given that x equal to s, right? Take a look at that. So it's more or less like you need to figure out the f of y given s, and of course to do that, of course, basically going to be f of xy divided by f of x. Okay, so which is the conditional function of y given s? Do you know from the same question? I can also figure out the conditional function of s given y, which is also going to be a joint divided by f of y. Okay, I can do the same. And when I do that in B part now, the B part now is asking you to find the probability of y greater or equal to 25. Of course, if y is greater or equal to 25, means you're going to go from 25 to the maximum. So which means I'm actually, going to use here, I'm actually going to use f of y to do that. okay, where I'm actually going to use the range of y to be that. But you know what, before I can use f of y, I need to first figure out what is the marginal function of y given the joint. Okay, now, like I said in class, you don't need to you need to leave C for now, because next week what we're going to start is mathematical expectation, where we're going to talk about the mean, the variance, the conditional mean or conditional mean. So that is being reserved for chapter 4, I mean the C. But what I'm going to walk you guys through now is A, B. Okay, that's what I'm. So the A and B is actually solved here, but I'm going to, like I promised in class, basically going to show you all steps leading to this. Okay, now that's what I'm actually going to do. So I think what I'm going to do at this time, I'm going to share my whiteboard. Okay, like I said, we need to first decide on, what is K. So give me 1 second. I'm going to stop my share now. Okay, so, and I'm going to share my whiteboard. Okay, so that's my whiteboard now. Okay, so what I basically want to do now, okay, don't forget, you have f of x, y. Okay, you have f of x, y given as k into s squared plus y squared. And of course, we in the range of x is basically from 20 to 30. And the range of y is also, of course, the X and Y has the same range. Don't forget, we're basically talking about tires, right? The pressure in tires, right? Both left tire and the right tire, of course, we expect them to have the same state space. Okay, so you're going to recall what we've done before that I said negative infinity to infinity, negative infinity to infinity. F of x, y, the x, the y must be equal to 1. I think you know that. Okay, so this must hold. Okay, now what I'm going to do now, okay, I'm actually going to plug in the f of x, y now. Then I'm going to use the range. Okay, so integral 20 to 30, 20 to 30, okay, k, okay, s squared plus y squared dx, the y equal to 1. Okay, I think you're seeing that now, right? Okay, so, if you take a look at what I have, now you basically going to see I can decide to bring k out. That's a constant, right? And I'm going to write integral that integral this. Then I'm going to do s squared plus y squared. Okay, the x, the y equal to 1. You see that? Okay, now when I have this guy now, okay, now I want to start my integration with respect to x, after which I'm going to do that with respect to y. Do you know you can also do, you may decide to start with respect to y, okay, before you go to the respect to x. There's no problem about that, provided you're using the right state space. Okay, now I'm going to clean my board now. So I'm basically going to move. So I want to start my integration from there. Okay, so I basically want to start my integration now. From integrating that, I want to do my antiderivative now with respect to x. Okay, that's what I want to start with. Get what I mean, right? That's what I want to start with. Okay, so I want to integrate this guy now with respect to x. You get what I mean, right? Respect to x, I'm actually going to have x to the power 3 divided by 3, right? Plus x y squared. Okay, don't forget, from 20 to 30. Okay, then I'm actually going to have another integral. Okay, don't forget there's a k here, and whatever I got here, I basically want to integrate with respect to y, and plug that guy to equal to 1. Take a look at that. Okay, so I'm going to clean up now. Okay, I'm actually I'm actually going to clean up now. Okay, so what I'm going to do now, just to plug in 30 in place of x. Don't forget, initially I integrated with respect to x. So don't forget, I'm actually going to have 30 raised to power 3 divided by 3, 30, okay, y squared, okay, minus, I'm actually going to plug in 20, okay, now 20 y squared, okay, and when I'm done, the y that equal to 1. Don't forget that. So all what I'm just going to do now is to simplify that guy. You can see why I said the knowledge of integral, the knowledge of algebra is also being required. You get what I mean? Now, when you take a look at 30 raised to power 3, 3 times 3 times, that would be, 27,000, 27,000 over 3. And when you take a look at 20 raised to power 3, that would be 8,000 over 3. So when you do 27,000 minus 8,000, that will give you 19,000. So what I'm going to have now, so I'm going to have integral, this is 30. So I'm actually going to have 19,000 over 3, okay? When I have that guy, 30y squared minus 20y squared, okay, that is basically going to give me 10y squared. That is basically going to give me 10y squared. And don't forget, what is the next operation that I actually want to do now, right? The next operation I want to do now is to integrate with respect to y. Take a look at that now. Okay, so I want to integrate with respect to y now. So integrating with respect to y now, okay, don't forget the constant is basically going to be 19,000, right? 19,000 over 3, right? Don't forget that. Okay, so if I integrate that guy with respect to y, I'm actually going to have 19,000 over 3y. Okay, the other guy is basically going to be 10y raised to power 3 divided by 3. Okay, then I'm actually going to go 20 to 30. Then I'm actually going to put 1 here. And don't forget, okay, there is a k, a constant outside. That's exactly what we're looking for, right? Okay, so do you know I can simplify it to say k over 3 into 19,000 y plus 10 y raised to power 3. Then from 20 to 30 equal to 1. That's what I'm going to have, right? Take a look at that. Okay, so I got k over 3 into that now. And what I'm basically want to do is to just plug in 30 into where I got y. Then I'm going to plug in 20. Then I'm actually going to subtract that, right? So now, right now, I'm basically going to have k over 3 into 19,000, right? Into 30 plus 10, right? Into 30 raised to power 3. Okay, don't forget, you're going to subtract, you're going to put 19,000, 20, okay, plus, 10 into 20 raised to power 3. Okay, don't forget everything equal to 1. Okay, so the moment you have this guy now, that is basically what I'm actually going to simplify. Okay, that is exactly what I want to simplify now. As you can see, what is going on. Okay, so I actually want to simplify all of that k over 3. When you multiply that guy, I think 19 times 3 is going to be 57. I'm actually going to have 4 zeros plus, okay, 30 ratio 30 ratio power 3. I think I'm actually going to have 27,000,000 minus 19 times 2. Okay, when you see 19 times 2, and basically, oh my god, this should be 19,000 here. Don't forget, I said 19,000 here that we go here. So I'm actually going to have 38, 1 2 3 4, right? Okay, minus this is going to be 80. Okay, that is going to be looking like 80,000, right? Take a look at that because of what you see there. And don't forget, everything equal to 1. So what you're going to do now, okay, if you simplify that, okay, so 570,000 plus 270,000 minus 380,000, okay, minus 80,000, okay, where you do that, that will basically give you 380,000. In fact, take a look at this. If you take a look at what I actually have right here. Okay, so when you simplify that, that's exactly what you gonna get. You're gonna get 380,000. So if I want to rewrite now, okay, so you can actually use your calculator. Okay, you can use your calculator. So like I said, when you do 570,000 plus 270,000 minus 380,000 minus 80,000, automatically you're basically going to get 380,000. That's exactly what you actually going to get. So right now, so what I now have now, so going forward, k over 3 into 80 into 380,000, right, equal to 1. Okay, so automatically my k is going to be 3 over 380, 80,000. Okay, so this is going to be your k. So take a look at that. That is how we derive k to be 3 over that. So I'm actually going to go into the lecture slide now. I basically want to show you. Okay, so I want to show you that the values of k is actually what I'm displaying now. So take a look at that. You can see now, you can see that 3 over 380,000. That was how we got k to be equal to that. Okay, so the next thing now is how do we actually get f of y given s to be that. Okay, don't forget where your k is 3 over 380,000, and how do we get f of y equal to that? There's something I wanted to pay attention to. The only difference between you know the f of s given y and f of y given s is just like y square here and s square here. Why is it like that? Don't forget the joint that we have is k into s squared plus y squared. Okay, and they got the same state space, and that is the reason why the result is basically going to be similar. So I'm going to show you how to figure out f of x now. Because if the same way that I'm actually going to show you how to do f of s, you're going to do f of y the same way. Okay, so let's get started. I'm going to show you now. I'm basically I'm going to share my whiteboard again so that you'll be able to see. Okay, so I'm going to clear my whiteboard now. Give me 1 second. Okay, now I just clear my whiteboard, and of course, our f of x, our f of xy, okay, which was k into s squared plus y squared. Before, we've already decided on k. 3 is 380,000. Okay, and of course we are having s squared plus y squared, right? This is the join now, and don't forget the range of x and y is from 20 to 30. Okay, now I actually want to get f of x, right? Okay, if I want to get f of x, I'm actually going to integrate that with respect to y, present the range of y, which is going to be from 20 to 30. Okay, so right now, so I'm actually going to do integral 3 over 380,000, right? And s squared plus y squared, the y. Okay, so this is basically what I want to figure out now, right? Okay, so this guy, I can bring this guy out. That's a constant, right? Okay, so that's a constant. Okay, so I'm actually gonna bring that guy out. It's a constant. Like I said, don't forget, the state space, the state space still remain from 20 to 30. Okay, so when I don't forget what I'm actually working on is f of x, that was y. I'm integrating with respect to y. And of course, if I bring this guy out, so if I bring this guy out now, so I'm just going to be left with this guy, s squared plus y squared, the y. Now, I basically want to integrate now with respect to y. Of course, s is going to be regarded as constant. You know that, right? Okay, so I got 3 over 3, 80,000. Okay, that's going to be s squared y. And that's going to be y cubed divided by that. That is, I'm integrated with respect to a y. Then from 20 to 30. Okay, now 3 divided by 380,000. Okay, now don't forget, I'm actually gonna plug in 30 in place of y. Okay, so that's gonna be 30 s squared, okay, plus, okay, so 30 raised to power 3 divided by 3, then I'm gonna do minus 20 s squared, okay, plus 20 raised to power 3. I think you can actually see that now. So all what is left now is just I'm gonna simplify. I'm done with my integration, right? I'm just gonna simplify. So I'm actually gonna have 10s squared, right? If you take a look at that, right? Then I'm also going to do the same here, right? So 30 raised to power 3, that should be 27,000, right? And 20 raised to power 3, that should be 8,000, right? So by the time I do 27,000 minus 8,000, automatically I'm actually gonna have 19,000, right? I'm gonna have 19,000 divided by 3, right? This is what I'm actually gonna have. Now, if I got this guy now, okay, if I got this guy now, all what I'm just gonna do is just to simplify. Okay, so how am I gonna simplify? You're gonna see now. I told you when I started, I said you're basically gonna be needing the knowledge of algebra, you need to know how to simplify. So right now, so that's exactly what I want to do, right? So this is our f of x, but it's not that in the final stage. We can still simplify that. So I'm actually gonna have, okay, so this guy multiplied by that. So I can just say 3 over 3 80,000, okay, 10 s squared, okay, and plus, okay, 3 over 3 80,000, okay, then 19,000 divided by 3. I think you can see that now, right? Okay, no, it's 3 here, cancel that 3, right? Okay, let me see, 3 zeros, don't forget, we got 40, 380,000, okay, that is basically going to cancel 3 of that. So by the time you do 19 divided by 380, okay, if you do 19, okay, you can use your calculator, right? 19 divided by 380, that's going to be 0.05. Now, if I now want to rewrite my answer, I'm going to show you. Okay, if I want to rewrite my answer now, okay, um, I'm actually going to have, so this is going to be 3 over 380,000 10 s squared plus, right, is 0 point, that would be 1 divided by 0.05. Okay, take a look at what I just done. The 3 has canceled that, and that goes in that. Okay, so we are actually going to have, as you can see, what is being displayed. I mean, sorry, 0.05, because if you use a calculator, okay, 19 divided by 380, that would be 0.05. And another way I can write this is to say f of s, k 10 s squared, right? Where's the k? Don't forget, that was the k that we got the other time, right? Okay, plus 0.05. Okay, that's another way to write that. Okay, so when you take a look at this answer now, I will quickly show you, what we got the other time. Okay, Oh my God, look at that. 10k s squared plus is 0.05. That is the f of x. Do you see that now? That is how to derive that. The essence of getting back at k, no, don't forget, k is 3 over 380,000. Do you see that now? Okay, that's exactly what we got now. That's our f of x. Okay, so that is our f of s. You see that, guy? Oh my God, that's super easy, right? So you can see, so that's why we call that. So another way to write that, you can say 10k s squared plus 0.05. But let me tell you this. You're also going to get the same thing for f of y. Don't forget, because of the function that you have, okay? And the x and y has the same state space. Your f of y, if you try f of y, okay, you're also going to get 10k y squared plus 0.05. That is what you're going to get. Okay, so that explain this guy now. Okay, that explain what we have here. You see now, that explain how we got that. This is your f of x. The same thing, you're going to get that for f of y. You see the difference? Okay, now the moment you are done with that, then you can actually use this guy. So, that's your joint. You are done. You see that? You already done. And of course, you can now answer a question that has to do with y given, y probability of y greater than or equal to 25, given s equal to 22. Don't forget, you're basically going to use f of y given x here. Look at that. And the f of y given x you are using this guy here. Okay, so what you need to do, first plug in s equal to 22. Anywhere you see s, that is what you see us doing here. First plug in s equal to 22. The remaining one is basically going to be a function of y. You see that? You have any function of y now. Okay, so all we just need to do is to integrate that guy from 25 to 30. And don't forget, when you integrate this guy, don't forget your k. You got to put k in at the end of the day. And your answer is going to be 0.783. And similarly, what if they ask you to find this guy here? Okay, the probability of y greater or equal to 25. Okay, what if they ask to find that? You're only going to use the f of y that you got. Don't forget, this guy is f of y. Okay, the denominator here is f of x. Okay, if I want to answer a question that has to do with y greater than or equal to 25, I'm only going to use f of y only, which is what I'm using here. I got it 0.75. Now, if you want to answer a question whether x and y are independent here, they are not. They are not, because this guy that you got for this is not the same as this guy. Okay, don't forget the probability of y given s. If it is equal to probability of y, it means y and s are independent. Okay. I think I've been able, like I said, I'm not going to go over this guy now. I'm going to leave that for next week. Next week we're starting chapter 4, mathematical expectation. Okay, so this is going to be covered under the mathematical expectation. And of course, I remember in class, I also talk about the bivariate normal distribution. Why do we need is, of course, when we're focusing on univariate, when S follow normal distribution, okay, when S follow normal with parameter mu and sigma, of course, I said the f of s is going to be 1 over square root of 2 pi sigma squared exponential raised to power that x minus mu over sigma all squared. Okay, so let's say I got a mu of x and a sigma of x. I can indicate x, I can indicate x here, I can indicate x here. And I'm also going to get the same thing for y. What if y follow normal distribution with a mu of y, sigma y? Okay, the same way I'm actually going to have 2 pi sigma y squared exponential raised to power that y minus mu of y, the sigma y all squared. What you see me writing now is more or less like the marginal distribution of x. and the marginal distribution of y. And the only way we can actually get this guy out is when rho equal to 0. When rho equal to 0, when you take a look at the join now, what of in a situation where x and y are jointly normally distributed, okay, where the mean of s, when s follow normal distribution, or the mean with the mean of s, the sigma s, and the y follow normal distribution with the mean y, sigma y. Of course, this is going to be the joint that we call it bivariate normal. Okay, when you take a look at rho now, that is your correlation. And let me tell you this: when rho equal to 0, okay, what are you going to have? When rho equal to 0, this guy is going to go away, right? And this guy is just going to be 1 over 2. So I'm basically going to have 1 over 2. Okay. When I have 1 over 2, okay, and what I'm basically going to have is, if you take a look at this part, I'm only talking about the exponential part here. Okay. Now, when rho equal to 0, you basically going to have the f of x. You're going to have f of x that multiply f of y. Okay. And don't forget, when the f of x multiply f of y, and if that is f of x, y, then you are trying to say x and y are independent. If x and y are independent, you expect the correlation to be equal to 0. Does that make sense? Okay. So, which is what I'm talking about here. Okay, this is a condition for independence. It's another condition for independence. Take a look at that. Okay, when f of s given y, the same thing as f of s. When the conditional distribution is the same thing as unconditional, of course, they are independent. Okay, so otherwise, they're basically going to depend. Okay, so I also, walk you through this. Of course, you know how to go about this guy now. So that was what I started. You follow what we did the other time that I started with, so you be able to answer that. So the last thing I actually want to walk you through today is I wanted to look at example 8. You're given a distribution like that, and of course, if you want to investigate whether f of x, y, whether x and y are independent. The only way to investigate whether x and y are independent is you need to first get the f of x, and you also need to get the f of y. Okay, so if you follow what we've been doing, this is, this range actually means x start from 0 to infinity, and this range means y start from 0 to infinity. So if this is the joint, so I need you to go and check that the f of x, where you integrate that, lambda mu exponential raised to power lambda x minus mu y. Okay, now, when you integrate that with respect to y over the range of 0 to infinity, okay, so that is basically going to give you this guy here. This is going to be f of x. When you do the same, f of y, okay, which is going to be lambda mu exponential raised to power minus lambda s exponential raised to power mu y dx, that will automatically give you that guy. So which means if you multiply this guy out, it's basically going to give you the joint. And because of that, we're going to say x and y are independent for that. Now, the last thing I'm going to do today before I go, I wanted to look at question 9. You can try that example 8 out. Okay. Now, when you look at the question 9, okay, you have that f of x, f of xy equal to x exponential raised power minus x, 1 plus y, and x greater than 0, y greater than 0. And of course, you want to find the marginal densities, okay, f of x and f of y, and check if are independent. Of course, the only condition under which x and y are independent is if the joint can be written as a product of the marginal. So which means if you want to investigate that, you need to first get what is your f of x, what is your f of y. And of course, in question 3, that said compute the probability of s greater than or equal to 2 given y greater than or equal to 4. Sorry, not giving. This is not giving, sorry. This is like a joint. the probability of x greater or equal to 2, comma y greater or equal to 4. So I'm going to show you how you're going to do that. Don't forget the range of x, don't forget the range of y, except that in this question 3, you're going to go from 2 to infinity, and for y, you're going to go from 4 to infinity. Okay, so take a look at, I told you we're basically going to start with the f of x. Okay, now I basically, the joint that you are given is this guy here. Okay, and if the joint you are given is that, you want to figure out f of x. Okay, now I told you the other time, you basically need the knowledge of algebra, okay, and calculus. Okay, so what I'm going to do now, I'm actually going to share my screen. Okay, I'm going to show you how you can figure out, okay, the f of x and the f of y. Give me 1 second. Okay, so I'm sharing my screen now. Okay, I'm showing my whiteboard now. Okay, let me clear all this up. Okay, so what I'm basically want to do now, okay, you have f of s comma y given equal to x exponential raised to power minus x 1 plus y. Okay, do you know, I can actually try to split that into that and exponential raised to power minus xy. I think you know that that's an algebra. I'm still simplify that guy now. Okay, so what I'm gonna do next now is basically, I want to find f of x. If I want to find f of x, of course I need to integrate f of x y, the y. The range of y is going to be from 0 to infinity. Okay, so don't forget what I want to do now. Okay, I'm going to focus on the guy. So x exponential raised to power that and exponential raised to power minus xy dy. Okay, now I need you to to look at that now. So if I basically want to get my my f of x, okay, now I want to get my f of x now, and I'm going to integrate with respect to y. Automatically, I'm going to bring the o of that guy out. So x, because they're going to be constant. Don't forget, I actually want to integrate with respect to y. You see that? Now, if I integrate with respect to y now, basically going to have exponential raised to power that. So integrating that now. So don't forget I'm doing that with the respect to y. I'm actually going to have divided by minus x from 0 to infinity. I can do x cancel s. So that's what I'm actually having now. Is basically going to be negative. If I have negative, okay, so I'm actually going to have e raised to power minus x. And don't forget, e raised to power minus xy that I got here. Okay, that one guy and that guy also, so when I have that guy now, okay, I can simplify before plugging in 0 to infinity. Okay, so what I'm going to do now, so my f of x is basically going to be I'm having a negative, okay, exponential. Okay, so I can actually have minus x into 1 plus y. You know that? And from 0 to infinity. So that's what I'm going to have here. When you simplify, exponential raised to power minus x, exponential raised to power minus xy, that can bring out minus x. And that's basically going to be that. Okay, so what do I have right now? So I'm actually going to plug in infinity. So that's going to be minus. Okay, don't forget the infinity that I'm actually plugging now. Okay, I'm plugging that in place of y. Don't forget I've integrated with respect to y. So I'm actually going to have 1 plus infinity. Okay, minus exponential minus x, 1 plus 0, right? Okay, the whole of that guy is going to be negative, going to be 0. Okay, don't forget the rate of decay, right? The rate of decay, exponential raised to power negative infinity is basically going to be 0. I think you know that. It's going to be 0. Okay, so the next thing I'm actually gonna do now is negative negative, that's a plus. Then I'm basically gonna have this guy. Oh my God, because 1 plus 0 is gonna be 1, right? This is my f of x. My f of x equal to that guy. Okay, that is my f of x. Now, similarly, you're basically gonna find f of y. You know, in the lecture note, I did not show you. Of course, I show you. I'm gonna go back to the material now. So you're basically gonna see that you know the f of s. Oh my God, f of s is exponential raised to the power minus s. Do you see that now? That was what we got. I think I just show you now. Now, the last thing I want to show now, what about f of y? Don't forget, in the material, the f of y was 1 over, 1 over 1 over y plus 1 all square, right? Okay, let's see. I'm going to show you that. Let's go there. Going to see now. Okay, so I'm going to share my whiteboard again. And I'm gonna, clean my board. Okay, so don't forget what we're dealing with. Okay, what was the f of xy? The f of xy is basically x exponential raised to the power minus x into 1 plus y. And of course, I expand that to be, oh, excuse me, this guy, that guy, right? And what I want to do now, I want to find f of y. Don't forget, if I want to do that, I'm going to use this formula with respect to x. The range of x is from 0 to infinity. And right now, I want to integrate with respect to, I want to integrate with respect to x. Okay, and of course, if I want to do that with the respect to s, I don't necessarily need to split that into this because I got x in all of that. So it's better I go back to the original function, that is x exponential raised to the power this 1 plus y, and the x. And of course, this is a function of x, this is also a function of x. We're actually going to use a quotient. There's a rule that we call integration by parts. Okay, we're going to use integration by parts. Okay, because we got s is a function of x, and exponential is power minus x into 1 plus y is also a function of x. So what I'm going to do here, I'm actually going to use integration by parts. Remember, I told you that the knowledge of calculus is actually needed. Okay, so what I'm going to do now, okay, I'm actually want to use integration by parts. Okay, so don't forget, I'm actually working on f of y. Okay, in integration by part, when I get to function like this, it's basically going to be first multiplied by integral of second minus integral of derivative of first multiplied by integral of second. Okay, now what is the first? Okay, x is going to be first, and the entire thing here is going to be second. Okay, so I need you to take note of that. So what is that first? First is x, right? Okay, multiplied by integral of second, it means I say write that guy inside integral. Don't forget, I'm integrating with respect to s minus integral of the derivative of first. If I differentiate x, that's going to be 1, right? So if I put 1 multiply by this integral of the second, okay, integral of the second. Okay, now what I'm gonna do now, oh my God, it's getting, it's easy now. Okay, don't forget, we're actually working on f of y, right? Okay, so I'm actually gonna have f of y. Okay, the f of y, integrating this guy now. Don't forget, we are integrating with respect to x. So that's basically gonna be, I'm gonna have this guy. Okay, don't forget, with the respect to s, it's gonna be negative 1 plus y. Okay, minus, of course, when you do that, the same thing here, and you put it under integral sign, okay, you're basically going to have exponential raised to the power that's 1 plus y. divided by minus into 1 plus y. Okay, and you're going to put that inside another integral. Okay, so and the next thing you're basically going to do, so far so good, right? Okay, that's super easy, right? Okay, so what you're gonna do now, okay, you basically gonna have f of y equal x exponential raised to power minus x 1 plus y, okay, divided by negative into that guy, okay, minus minus, that's going to be a plus, right? And when you integrate that guy again, oh my god, after becoming plus, right? Okay, I'm actually going to have this guy 1 plus y, and there's going to be another 1 plus y. Don't forget that it's going to be 1 plus y squared. And you know, because that's also going to call with negative, then the whole thing here is basically going to be negative, and I'm going to do 0 to infinity. Okay, so when I do 0 to infinity right now, the next thing that I'm actually going to do is just to plug in infinity into where we have x, and we're going to plug in 0. Okay, so let's see what we're going to have now. We're almost getting to the finish line. Okay, almost getting to the finish line. Okay, so when you plug in infinity into where you have, it's more or less like put infinity here, they're all going to go to 0, right? So don't forget, let's say the whole of that actually gives 0, then minus when you now plug in 0. Okay, so when you plug in 0, so 0 1 plus y, okay, divided by minus into 1 plus y, okay, minus e raised to power minus, don't forget you're plugging in 0, okay, 1 plus y, okay, divided by 1 plus y or squared. Okay, now there's a negative here, there's a negative here, there's a negative here, all of that. Of course, the further you have 0 here, this guy is going to go away. We're only going to be we're going to be left with negative, negative, going to be a plus, right? And that is, oh my god. So what we that actually fetch me now? Okay, so I'm actually going to have negative into 0 1 plus y, okay, divided by 1 plus y all squared. Oh my god, all of that is going to be 0, and anything raised to power 0, that is basically going to be 1. Oh my god, the final answer is going to be 1 over that is going to be your f of y. Okay, that is how we derive that. Like I said, you basically need to revisit what you've done before in calculus to be able to get along. Okay, let's see. Let's compare the results to what we have in the lecture slide. Oh my god, take a look at the lecture slide now. That is what we just derived. So which means our derivation is actually right. Okay, in case if there's anyone who doesn't understand that, you can meet with me during my office hour tomorrow, 4 p.m. Chicago time. This is Minnesota time, Central time, 4 p.m. You can actually meet with me during my office hour. You can join me, or you can join me on Zoom. Okay, so we've already done that. The next thing we're basically gonna do now, answering a question on whether f of x and y are independent. Of course, for f of x, we got this guy. For f of y, we got this guy. If I multiply this guy by this guy, it will never, never give me the same expression as the joint. Okay, because the product of the marginal that I got will not give me the same expression as the joint. Then I'm basically going to say they are not independent. Okay, they are not independent, and that was why we choose they are not independent. Now, the last question now, I want to find the probability of x greater than 2, given that y greater than 4. Of course, since this is a joint, right? The only thing is just like, oh, x is going to go from 2 to infinity, and y is going to go from 4 to infinity. That's what you see here. And we're basically going to use the joint function that you are given. So you can do that one at a time. You can force integrate with the respect to y. Don't forget, when you are integrating with the respect to y, before you integrate with respect to y, you can actually simplify. Okay, if I have as I have x uh x exponential raised to power minus x into 1 plus y, I can actually split that into x exponential raised to power minus x exponential raised to power that, okay, which is what I have here. Okay, so why am I bringing anything that has to do with x out? Because I first want to start my integration, my antiderivative with respect to y. Okay, that was why I brought that out. So you need to first integrate with respect to y. And after you've done that, you plug in infinity and 4, you subtract. Then finally, you're now going to integrate with respect to x. And in the end, you're basically going to get that. So that is that. Okay, so I think, oh my God, that is the final thing. Like I said, watch this video. If there is any area you don't understand, please reach out to me. Make sure you stay safe and have a lovely day. Bye for now, everyone.